All right, as we take a look at this, what we want to do is to make sure that we have the similar parts of the triangle. We can see our triangles that are created. We have the large triangle right here, and then we have a smaller triangle right there. So let's identify the parts that we do have. On the smaller triangle, we have both the, I guess technically our triangle is the person. So we're going to slide over a little bit. So our triangle is here. So on our small triangle here, we have a side length of 1.35 meters. And that's the bottom of our triangle. We also have what I would consider the medium side of this triangle, but we have to do a little bit of calculations in order to do this. We can see that the distance from the point is 16.95. And then we can also measure that he is 12.8 meters away. So we can figure out that this missing portion here is 4.15. So here's what we need to set up. We need to set up these. What I'm doing is I'm setting up the small side of the triangle compared to the medium. That would be 1.35 compared to 4.15. Well, we need to do the same parts of the larger triangle. In this case, we don't know how tall the tree is, which is the one that relates to the 1.35. So that's going to be our variable x. But we do know the length of the medium side of this triangle, which is the 16.95. So we're going to cross multiply here 1.35 times 16.95, which is 22.8825. And then the other side is 4.15 times x. So we'll divide by 4.15, and we learn that our tree height is 5.51. All right, so in this one, we're going to have to construct our own picture. We can clearly see Daniel stands 1.45 meters tall at high noon. He measures the length of a tree shadow. So we've got a tree here, obviously. Beautiful tree right there. And the shadow of the tree measures 17.65 meters. And he is standing 12.5 meters away from the tree. So it tells us the tip of his shadow is now matched up with the tip of the tree shadow. So that's the construction of our triangle here. And it's asking us, just like on the last one, except for we're constructing the picture here, how tall is our tree? So what we've got to make sure we have is corresponding parts on the particular triangles. So we can see that the triangle we're looking for is the x over the 17.65. And we need to find the parts that relate to this on the smaller triangle. So this would be 1.45 compared to this amount from here to here. Well, that's going to be so the part of the triangle that correlates with this is basically Daniel's shadow. And Daniel's shadow measures 5.15 meters. And we know this because we subtracted 17.65 minus 12.5. So once we have the corresponding parts here, we can cross multiply and see what we get. This is going to be 5.15x equal to 1.45 times 17.65. $25.5925. We're going to take this amount and we're going to divide by 5.15. And then x equals 4.969, so it rounds up to 7. So the first thing we're going to notice here is we're going to identify all the parts to our thing. So it says CF is 20, FG is 25, and CD is 45. So the only corresponding parts that we actually have here are the 25 and the 45 are respectively the bottom parts of their corresponding triangles. Now, what we have to set up now is another corresponding part from the small triangle to the large triangle. What we're looking for is the measure of FE. So we're going to label that with an X because it's an unknown amount. So I've got the smaller triangle in the numerator, so the X is going to go into the numerator of the proportion that I'm setting up. So the second part of the proportion is going to be the second side, or the side of the larger triangle. Well, that's from C to E. Well, that's a combination of X and 20, so we would set up X plus 20. Once we've done that, we've got our proportion set up, and we are going to cross multiply just like this. This gives us the result of 25 times X plus 20 equals 45X. Now, at this point, we are going to distribute the two terms. And 25 times 20 is going to be 500. So we are to this point. We will then subtract 25 from both sides. So 500 equals 20x. We divide by 20, and we find that x is equal to 25. Always double check to make sure that that's what you were solving for. And in this case, we were solving for that because it asked me for FE, and FE I did label X. So that's all we need to do on this one. All right, as we see this one, we have parallel lines NO and KL, so we have corresponding parts that are happening here. And I have this figure in a little more visual effect here. And we can see that the side KM is 15, the side NO is 7, and the bottom value is unknown, which is X. So we're going to have to set up some corresponding parts here that are a little bit different than we were dealing with. So I'm going to try to maximize this and show you a little graphic of how we can split these values into two separate triangles. So you can see how that is happening there. We're splitting those into triangles one more time, the larger and the smaller triangle. And then we see this value here. So this one, we don't have to do the adding like we did earlier. We can just set up our triangles here. And I had another picture that is eluding me. So we'll just go here and construct our two triangles. we have a triangle with a side of x and a side of 7. And then we have another triangle that has a side of 15, which corresponds with the x. And then it told us that those two sides are equal, so this one is also x. So we're going to set up this proportion just like we see. X is to 15 as 7 is 2x on the other triangle. So we can compare these parts this way, just make sure these are corresponding parts. So x times x is x squared, 7 times 15 is 105. So I'm going to take the square root of both of these, and x equals the square root of 105. And it tells me to leave it in simplest radical form. Well, 105 doesn't have any factors that are a perfect root, so that is just our answer. So on this one, we're told that the diagonals, the diagram below PQ is parallel to MN, which means we're going to have some corresponding parts again. QE is 5 less than PO, MO is 45, ON is 36. Guys, I can't express enough how important it is that you diagram these different things. Trying to make this one larger. Oh well, we'll just go from this picture here. So make sure that you do diagram these values, and then we set up the parts of the triangles that do correspond. So we can clearly see we have on one triangle a couple of sides. We see on the small triangle x compares to x minus 7. Those two are on the same parts of the triangle. We don't have to draw from the different triangle. We just have to make sure the parts do correspond together. So since I put this portion of the triangle on the top of one side, the corresponding part on the large triangle has to be on the top of the other side. So this would be 45, and this side would be 36. Once we have this, what we're going to do is cross multiply 36x, and we're going to cross multiply here, which is 45x minus 45 times 5 is 225. So I took the liberty and did the distributive property there at the same point. If you don't understand that, that's fine. Just pull me to the side. I'll see if I can help you with this. So we're going to now, I generally like to move the larger to the smaller, or the smaller to the larger, but in this case, I'm going to move it this way, so I only have to move one thing. So this is going to be negative 9x equals negative 225. So when I divide by 9, I'm going to learn that my x value is equal to 25. Now let's go back and make sure that I actually answer the question that was being asked. The question says, find the length of PO. Well, PO was from here to here, which is a value of x, so PO is 25. So that would be all we need to do on that one. Last one. Now, the last one we're going to take a look at, CE, so larger segment here, has a measure of 28. FG, bottom of the small triangle, is 14. And it says CD is twice the measure of FE. So let's call FE x, which would make CD 2x. So now we have our parts of our triangle here. The left side of the small triangle is x over 14, which is the bottom, compared to the left side of the larger triangle, 28, compared to the bottom, 2x. Just like we've been doing, we're going to cross multiply. Excuse me. 28 times 14 is going to be 392. I'll divide both sides by 2. And it tells me this x squared is equal to 196. And the square root of which is 14. So I've established that x is equal to 14. I assign x to be FE. So I am done because I made FE x, then FE does have a measure of 14. All right, that's a few examples. Maybe that will help you on that delta math. Good luck.